Dear children, today we are going to study about the topic atomic structure. The structure of an atom that consists of many particles that we are going to study over here in detail. So listen to it and concentrate on it whatever is being taught. Democritus only gave a vague concept about the elements being composed of atoms but did not give much details. He was a Greek scientist. He was the first to put forward the idea of elements splitting into minute particles. He named these particles as atoms, which means indivisible. Later, in 1808, John Dalton, an English scientist, proposed an atomic theory known as Dalton's atomic theory. The main points of Dalton's atomic theory are: elements are made up of small indivisible particles called atoms. Atoms of a given element are identical but differ from the atoms of other elements. Atoms can not be divided, created, or destroyed. Atoms of different elements combine in simple whole number ratios to form chemical compounds. Atoms. J.J. Thomson, he was another scientist who studied the characteristics and constituents of the cathode rays and concluded that cathode rays consist of negatively charged particles, now called electrons, present in atoms of all the elements. He performed an experiment in which he found that when he applied an electric field in the path of cathode rays in the discharge tube, he observed that cathode rays were deflected towards the positive plate of the electric field. This showed that cathode rays were negatively charged. When the magnetic field was applied in the path of cathode rays, they were again deflected in a direction in which moving negative charge would be deflected. This proved that cathode rays contained negatively charged particles called electrons. Now, in 1904, Thomson developed the idea that an atom was made up of electrons scattered unevenly within an elastic sphere surrounded by a soup of plastic charge to balance the electrons' charge, like plums surrounded by pudding. And this model is known as plum pudding model. According to this model, an atom is a positively charged sphere in which electrons are embedded just like dry fruits are distributed in a pudding. Since the total positive charge of an atom was equal to the total negative charge of its electron, it followed that an atom would become negatively charged if it gained electrons and positively charged if it lost electrons. However, this model failed to explain many experimental observations about atoms. Hence, Thomson's model was not accepted. In 1911, Lord Rutherford, a scientist from New Zealand, conducted an experiment in order to find the arrangement of electrons and protons in an atom. His experiment led to the discovery of a small, positively charged nucleus in the center of the atom. He bombarded a thin sheet of gold of 0.00004 centimeter thickness with alpha particles in an evacuated chamber. He observed that most of the alpha particles passed straight through the foil without any deflection from their path. A small fraction of them were deflected from their original path by small angles. Only a few particles bounced back. On this basis, he made conclusions like most of the space in an atom was empty because alpha particles went straight. There was a heavy positively charged mass in the atom which caused deflection of a small fraction of alpha particles. The positively charged mass is very small and is centrally located because only few particles bounced back. It was named as the nucleus of an atom. While doing experiment with the helium, they found that while most of the helium nuclei pass through the foil, a small number were deflected and to their surprise, some helium nuclei bounced straight back. Rutherford's new evidence allowed him to propose a more detailed model with a central nucleus. He suggested that the positive charge was all in a central nucleus, with this holding the electrons in place by electrical attraction. However, this was not the end of the story. Niels Bohr studied under Rutherford at the Victoria University in Manchester. Bohr referred Rutherford's idea by adding that the electrons were in orbits, rather like planets orbiting the Sun, with each orbit only able to contain a set number of electrons. Now we can see the helium atom containing of outermost shell a proton to a neutron as well as electron. In diagram, all the particles are clearly visible. Now what do these particles consist of? Now we can see the atomic structure. Now this atomic structure, it is led by the model of an atom. According to this standard model of an atom consists of the subatomic particles called electrons, protons and neutrons. There are two structural parts of an atom, the nucleus and the orbits or the shells. Shells are the extra nuclear part present in the empty space that surrounds the nucleus. The nucleus is the positively charged central part of an atom. It contains protons and neutrons. The protons and neutrons, collectively known as nucleons, are held firmly in the nucleus by strong nuclear forces. The entire mass of an atom lies in its nucleus. Since electrons have negligible mass, the positive charge of the nucleus is due to the protons present in it. The protons remain unaffected by the neutrons since the latter have no electrical charge. Then orbits or shells are the imaginary path traced by the electrons in the empty space surrounding the nucleus. Each orbit is associated with a fixed amount of energy. Therefore, these circular orbits are known as energy shells or energy levels. Electrons revolve round the nucleus in these orbits. The shell or the orbit lying closest to the nucleus carries the lowest amount of energy, and the shell that lies farthest from it carries the highest amount of energy. An atom is electrically neutral because the number of protons and the number of electrons present in it are the same, thus balancing the total charge of the atom. While the neutral atom of an electron has an equal number of protons and electrons, this number itself varies from one element to another. In fact, no two electrons contain the same number of protons or electrons. That is why each element differs from the other in its properties. We can easily see the difference between the three subatomic particles that is shown in the diagram. The particles like proton carrying positive charge and the mass of proton is 1. Neutron having no charge and its mass is 1. Then electron having negative charge and its mass is nil. So we can also say that electron has negligible mass. So in this way we can see the distribution of charges in different particles of an atom. Now if we see the helium atom, the atomic structure of helium atom, atomic number is 2, that is number of protons are 2 and the number of protons and neutrons in an atom are 4. That is your atomic mass. As we know that the mass number is number of protons plus number of neutrons. Electrons revolve around the nucleus in imaginary paths called orbits or shells. The orbit closest to the nucleus is called the first orbit. The next orbit is called the second orbit, and so on. They are labeled as K, L, M, N. And so the number of shells also we name them as first, second, third and fourth. Each of these shells contain different number of electrons depending upon the amount of energy associated with them. The shell closest to the nucleus has the lowest amount of energy and hence contains the least number of electrons. The rules that are applied for writing the number of electrons in different energy levels or shells are: number 1, the maximum number of electrons in each shell or orbit is determined by a formula 2n square, where n is the number of shell. Therefore, k shell n is equal to 1. Number of electrons are 2 into 1 square, that is 2. L shell, where n is equal to 2. Number of electrons are 2 into 2 square, that is 8. M shell, where n is equal to 3. Number of electrons are 2 into 3 square is equal to 18. N shell, where n is equal to 4. Number of electrons are 2 into 4 square, that is 32. Electrons are not accommodated in a given shell unless the inner shells are filled. That is, the shells are filled in a stepwise manner. 2n square is known as Bohr-Bury scheme, as it was given by the scientists Bohr and Bury. For example, hydrogen atomic number is 1, so electronic configuration K shell will be 1. Helium atomic number 2, electronic configuration in the first shell, that is K, will be 2. Lithium atomic number is 3, so in the first shell K is 2 and second shell is 1. Beryllium atomic number 4, first shell K, that is 2, and second shell is 2. Boron atomic number 5, first shell 2, second shell 3. Carbon atomic number 6, first shell 2, second shell 4. Nitrogen atomic number 7, first shell 2, second shell 5. Oxygen atomic number 8, first shell 2 and second shell 7. Neon atomic number 10, 2 electrons in the first shell and 8 electrons in the second shell. Thus, the maximum number of electrons in the first orbit is 2, in the second 8, in the third 18, and in the fourth 32. However, the outermost orbit of an electrically neutral atom cannot have more than 8 electrons. This is called octet rule. If the atom has only one shell, as in case of hydrogen and helium, the outermost single cell can have only 2 electrons, called as duplet rule. The rules of electronic configuration can be better understood by some examples. A helium atom has 2 electrons. They occupy the first and the only shell of the atom. Lithium atom has 3 electrons, 2 of which occupy the first shell and the third shell electron occupy the second shell. Neon atom has 10 electrons. The first shell takes up 2 electrons while the second shell 8 electrons. Thus, taking help from these examples, we can write electronic configuration of most of the elements. Now, dear children, thank you very much. I think you must have understood the concepts and liked the video. Watch it and try to understand all the concepts which have been explained in this topic. Again, thank you very much.